Okay, so hi guys, we're going to do a video on angles in a triangle, and there's a really special relationship about triangles. So what I've done is I totally just made this triangle up a few minutes ago. I cut this out. It's, the typical three-sided triangle. I didn't measure the angles or do anything special. All I've done is number them. So I called one of them 1, one of them 2, one of them 3. So I've got angle 1, angle 2, and angle 3. And we want to look at what do these three angles make up. And we can prove this a lot of different ways. One way we can prove it is by taking this triangle and ripping off the corners and taking the angles off. So I'm going to do that. I'm going to rip this triangle and I'm going to take all three angles off. And go like this. So now I've got them broken up into like 3 pieces. You can kind of see them on the screen here. And I want to show you what will happen if I fit the 3 angles together again. So I'm going to take each angle. I'm going to start with angle 1. I'll put it just like this. And then I'm going to take angle 3 and put it probably like that. And I could push these together and make them perfectly fit together. I'm going to leave a little space just so you can kind of see it. And then I'm going to take angle 2, the last angle, and fit it up like that. And look what happens when I take the 3 angles of the triangle and put them together. They form what looks like a totally straight line. And how many degrees are in a straight line? 180. So it appears that 3 angles in a triangle, if you put them together this way, add up to 180 degrees. There's another way we can prove this. This is kind of a, it's not a solid proof. It looks right. But again, there's space in between all of these. So let's look at another way to prove this. Alright, so we've kind of concluded that the 3 angles add up to 180 just by appearance. But now let's do a little more of a mathematical proof of this. So I'm going to take away the ripped up pieces of a triangle. And instead, let's look at a drawn picture of a triangle. It's kind of the same setup. It's got 3 angles. I numbered them angle 1, angle 2, and angle 3. And we want to prove that they add up to 180. So to begin with, I'm going to add some helping lines to this picture. I'm going to add a couple of things that I think will help me out. I'm going to take this line down here and draw a line parallel to it that goes right through the top of the triangle. And I'll put a little mark on here. So these are 2 parallel lines that I'm looking at. And then I'm going to extend the sides of this triangle. So I'm going to extend this side so it goes both directions, forming a transversal. And I'm going to extend this side to form a transversal. And to kind of help me out, I've got angle 1, 2, 3. I'm going to add angle 4 and angle 5 to the mix. One of the things we can see right away is that 4, 2, and 5 make 180 degrees on this straight line. So let's write that down. Angle 1 plus angle 4 plus angle 2 plus angle 5. These 3 add up to 180 degrees. We can see that pretty easily. Then if I look at some of this parallel line transversal relationships, I see that angle 4 up here and angle 1, if you look at this as a straight parallel line, maybe it helps to see it like this, they're alternate interior angles. And we know that alternate interior angles are congruent. We know that if we measured angle 4, it would be congruent to the measurement of angle 1. They'd be equal to each other. And we know that because they're alternate interior. So we're going to write underneath here, the reason for this is they're alternate interior angles. And we've learned all about these in class. And there's other videos on this too. So that's one thing we know. With the same idea, we could say that angle 5, we'll double mark angle 5 here, and angle 3 are congruent as well by the same reason, alternate interior. If you look at them, they're opposites from each other. They're on the inside of these 2 parallel lines. So we could say the measurement of angle 5 is going to end up equaling the measurement of angle 3. We could say they're congruent angles. And for the same exact reason, they're alternate interior angles. So alternate interior angles. So with this in mind, I'm going to do some substituting. This means that angle 4 and angle 1 are the same. So you know how we had angle 4 right here? Let's rename it and call it angle 1 since they match up. And we know that angle 3 and angle 5 are the same, so we had angle 5 right here. I'll rename it as angle 3. Oops, wrong color. Angle 3, because they're the matching. And then I'll just keep angle 2. I won't even change this, angle 2. And if I rewrite this with substitution, I now have angle 1 plus angle 2 plus angle 3 equals 180 degrees. So there's another way we can prove that three angles in a triangle, angle 1, 2, 3, add up to 180, just using some information that we've already kind of gained in class about alternate interior angles. So it's pretty safe to assume now that this is kind of a fact for us. So I'm going to write down here. This is called the triangle angle sum theorem. Triangle angle sum theorem. And it's one of these ones we start to memorize so that you don't have to go through the proof every single time. And it basically says that all three angles in a triangle add up to 180. So the angles in a triangle add up to 180 degrees. That's our triangle angle sum theorem. And if we know this information, we can solve a lot of different problems. So I'm going to give you an example of where you could use this. Example. This is the kind of stuff you see in the book. Let's say I have a triangle. I'm making this triangle up. And I tell you that this angle over here is unknown. It's x. I don't know what it is. But I know that this angle is 40 degrees. And I know that this angle is, let's say, 80 degrees. I don't think I drew it necessarily appropriately, but that's okay. So if I wanted to solve for x, it'd be so easy because I know all three have to add up to 180. So I know that x plus the 40 degree angle plus the 80 degree angle have to equal 180. Solving for x is going to be pretty easy for me. So this is x plus 40 and 80, if you add that together, is 120 equals 180. And if you subtract the 120 over minus 120 from this side, we're going to get x equals 60 degrees. So we know that this angle, x, is equal to 60 degrees. And the triangle angle sum theorem is what helped us figure that out. Now this is kind of an easy example. They can get way more complex. So you're going to see in the classroom when you start to practice these how these can get much harder. We can add some equations in here. I'm going to give you one last one for the video that's a little bit more difficult, and then I think you should have this down. So here's an example of a little bit more difficult one. Let's say you have another triangle. And this time I go in here and I tell you that this angle is, let's say, 2x. I don't know what it is. It's 2x. This angle is 96 degrees. And this angle is x plus 12. I can solve for x and I can solve for the angles. I can do both things at once here. I know all three add up to 180. So I'm going to make an equation out of this. I'm going to say, okay, the 2x angle plus the 96 degrees plus the x plus 12 all have to equal 180 when we're all said and done. So it's an algebra problem. Let's see, we got 2x and x. We got three x's here. Plus 96 and 12, I can add those together and say 108 equals 180. And let's just do some math here. Let's subtract the 108 over. Subtract 108. We're going to get 72, so 3x equals 72. And I'll divide by 3. I'll divide by 3. And I'll get x equals 72 divided by 3 is 24. Which is my answer for x. It's not the measurement of these angles. If somebody said, well, what's this angle over here? You'd say 2x is now 2 times 24, so 2 times 24. So you got to actually kind of do the math. Or like this one, it's not x, it's 24 plus 12. So let's check it. 24 plus 12 is going to be 36 degrees. And 2 times 24 is going to be 48 degrees. So I should write equals 48. So now we have a 48 degree angle, a 96 degree angle, and a 36 degree angle. And if you want to make sure you're right, you know all three of these should add up to 180. So you can easily check your answer. Here's what a check would look like. To check this thing, you just take the three angles. What did we get? We got 48 plus a 96, plus, I didn't mean to draw that line, plus a 36. There we go. I'm going to add up all of these. And if you add all this up, let's see, we get, 180. So we did it right. So just double check your work. Add them all up. Make sure you're right in the very end. Hopefully that helps. In class, you're going to work a lot more on these and get better at solving some of these algebra ones.